And we are back. This is expressions that play together, activity 2.2. And this activity, it is all about practice. You're going to use double number lines to solve two-step equations. Let's get started. I'm going to go ahead and read the directions so you know exactly what is expected while you work. Number one, it says model each equation on the double number line given. Then use the model to solve the equation and describe your steps and operations you use and explain your reasoning. Now, that was a lot of words. I'm going to break it down to you and model exactly what I expect for you to have on your papers as you are working, and also give you a starting point because if you notice, these double number lines are totally blank. So we are building from scratch. Clearly, I'm still at work. All right, let's get into it. So the first equation is 1 half x plus 5 is equal to 15. Now, like I said, there's nothing on this number line. So to help you out, the very first thing that you should put on any number line, you always start from where? If you said 0, you're brilliant. Go ahead and put a 0. And then also, the variable that is in our equation is an x. So I'm also going to put 0x on my double number line as well. Do you think it matters if I put it on the top or the bottom? No, it doesn't matter. But I am going to use my 0 to place my 15. So my equation, 15 on the top and 1 half x plus 5 on the bottom where my variables are. Alrighty, I've got my expressions placed on the double number line. Now, make sure you're taking these notes because this is the only one that I'm going to set up for you. In addition to modeling the equation, we just did that, we are going to use the model to solve the equation, meaning at the end, I should see x is equal to blank. And then lastly, you're going to describe your steps just like you did in the last activity. What was your first step? What was your second step? Some of them may have less steps. The goal is simply to isolate that variable. Alrighty, now that you know what's expected of you, take a look at the problems in front of you. You're going to solve for 1A. You're going to solve for 1B. You're also going to solve for 1C and 1D. And also, I want you to take a look at question number 2, and we're going to talk about that after all of these problems have been worked on. For this activity, you can work by yourself or you can work with a partner if your teacher allows. I do not advise groups. At this time, go ahead and set a timer for about 15 to 20 minutes so that you can work on 1A, B, C, and D. Pause here. Alrighty, now that you've had plenty of time to work on these problems, we're now going to compare your answers to mine. All right, for 1A, you should have gotten x is equal to 20. If you got that correct, go ahead and put a check. And use also the colors that I used to help you see what I did. So the first step, I subtracted 5 from both sides to then get 1 half x by itself is equal to 10. Now, I've got that 1 half x. Some of us can stop and think, okay, half of this number is equal to 10. However, also think of it this way. How many halves create one whole x? 2, right? 2 halves create a whole. So my second step was multiplying by 2. So 2 halves gave me one whole x, and then on the top, I also multiplied 10 times 2 to give us 20. If your work looks slightly different than mine, that is okay, as long as you've got the correct work and the conceptual understanding of how the double number line works. If you need to pause here to take these notes, go ahead and do that now. For question 1B, problem 1B, excuse me, there was only one step to do here. This was a one-step problem, so it should have been a little easier. The opposite or the inverse of -3 and 1/10 would be to then add or subtracting 3 and 1/10 would be to add 3 and 1/10. So I added 3 and 1/10 to both sides, and I made a mistake. See, I told y'all, mistakes happen. T is equal to 55 and 6/10. Go ahead and copy this down if you don't have that. Pause here. For 1C, you got 4 times b plus 1 is equal to 20. This is how you should have set it up. And the 2 steps that you would take to solve, well, I'll say this. Some of us seeing those parentheses in that group may automatically want to distribute. And if you distributed, that is okay too. That's absolutely acceptable because you'll get the same answer. However, I also wanted you to think of it this way. 4 times b plus 1 represents 4 groups of b plus 1. And if I have 4 groups of b plus 1, how can I figure out what is one group of b plus 1 worth? Well, I can divide that whole group by 4, which is what I did to both sides of that expression, both sides of the equation. So I divided the top by 4 and got 5. 20 divided by 4 gives you 5. And then 4 times b plus 1 will then divided by 4. Let me slow down. Will leave you with b plus 1. And then the inverse of that plus 1 would then be to subtract 1. When we subtract 1 from both sides, we are left with b is equal to 4. If you didn't get these notes down, or if you'd like to take these notes down specifically, go ahead and pause here. Moving on to 1D. This also was a one-step equation. The inverse of adding 4 and 5/10 would be to subtract 4 and 5/10. Also notice I started on the left side of my 0 because I saw that that negative 10, well, is less than 0. So that's why I chose to do that. But if you did it the other way, it's okay. We're learning, right? So you should have gotten m is equal to negative 14 and 5/10. Go ahead and take these notes. Pause here if you don't have these notes. Alrighty, and lastly, we've got question number 2 at the end. It reads, Brent showed how he started to solve the equation 1/2 x plus 5 is equal to 15. Describe his method. Then complete his process to solve the equation. If you haven't already, I want you to take about 2 minutes to work this out on your own. So pause here now because I'm about to go over your work that you should have or the solution to Brent's problem. Alrighty, let me go ahead and show you my work. Alrighty. If you did not get anything written down, go ahead and take these notes. As you can see, there were 2 steps to solve this problem. Brent started by, first in purple, multiplying both sides of the equation by 2. The reason he did that, well, you got that 1/2 x, and we saw something like that earlier. How many halves make a whole? Well, 2. And if you're going to multiply one side of the expression, one side of the equation, you're going to have to multiply the whole expression. So 2 times 1/2 x gives you 1 whole x, and then 2 times 5 gives you 10. So he then was left with 30 is equal to x plus 10. Then in green, the inverse of adding 10 is subtracting 10. So we did, subtracted 10 from both sides to leave us with x is equal to 20. Bonus points if you checked by plugging in that solution into the original equation. All right, go ahead and pat yourselves on the back because you did a job well done, you practiced well, and now you are proficient at solving, or should be. If you're not there yet, it is totally okay. We will continue practicing. But you've now solved 2-step equations using a double number line, and you will continue your practice on Mathia. Awesome job today.